Hey guys, welcome to another exciting episode of KLINGSPOR's Tech Talk. I'm Nick DeMars.
And I'm Nina Grum.
And I say exciting because we're excited. We have a new product line we're starting. We've been anticipating this for a while, and it's finally come D-Day. I mean, we've got some cool saw blades coming in, and they are thin kerf blades. Thin kerf blades have made a jump in recent years, and they're becoming more and more popular, and we figured we'd jump into that market. And you know, we already provide a high quality saw blade. Why not provide a high quality thin kerf saw blade?
Exactly.
So before we get into talking about the thin kerf blades an awful lot, we want to just look at general terminology. I know there's folks out there that might be just getting into woodworking. Some of you have never messed with it, might just be getting interested, but you don't quite understand what somebody's saying when they say, oh, I'm ripping or I'm cross-cutting. So we want to talk about that a little bit. So ripping and cross-cutting. We're going to talk first about ripping. Tell us a little bit about what ripping is.
Yeah, definitely. Ripping is cutting parallel or with the grain. If you think about the way that a tree grows and the way that those fibers run, they're running upwards. So when you were ripping, you were tearing those wood fibers apart or cutting it down to a certain width. So if I have a 5-inch wide board and I want to get it down to 2 inches wide, the kind of cut I'm going to be making is a rip cut.
Very interesting. It's interesting you mentioned the wood fibers and those running up the tree. When we consider the fibers running up the tree, when we cut that tree down and make it into a board, all of a sudden it's this way. So basically we're looking at this desktop right here and we see these wood fibers running with the grain this way. You might not think about it too much, but the way those fibers are running affects how the saw blade performs. We'll get into that in just a minute. So you talked about ripping already. What's the next operation?
So the next operation would be the exact opposite of that, and that is cross-cutting, which literally translates down to cutting perpendicular or across the grain. So another way to think about it is you're cutting a piece of wood down to length. So if I have a 10 inches long board and only need it to be 7 inches long, I'm going to be doing a cross cut to knock it back down to where I need it.
Interesting. And those wood fibers come into play again. I like to use the illustration of a bundle of straws. If you're taking a pair of scissors and you're cutting across a bundle of straws, it's going to clip those things off nice and clean. But then when you try to cut the other direction, it's going to separate those straws in some cases. So it's going to be a little bit harder for a ripping blade to perform its operation than it would be the cross-cutting blade.
Absolutely.
So, and we could talk about tooth configuration and stuff like that, but that's not necessary at this point. But it does beg the question, you're talking about doing ripping for 1 minute and then talking about doing cross-cutting for the next minute. That does seem like you could be changing out saw blades quite a bit. What can we do to kind of combat that?
And we come across this a lot. I mean, if I was a shop owner, I wouldn't want to always go from changing one blade to a different blade. So we have 2 blades that'll really do both, and that is the general purpose and the combination blade. The types of cuts that they make are going to be a little different, but those are the 2 options we have that'll make a variety of different cuts.
Okay, so what is the difference between general purpose and combination?
So the biggest difference is your general purpose is going to cut a lot faster, but it's going to be more of a rougher cut. Your combination is going to cut relatively slower, but it's going to be a lot cleaner and neater of a cut. And if you look at these blades here in front of us, what makes them different is that your combination blade has those large gullets. And what those gullets are doing is they are gathering the sawdust and they are pushing it into the gullet for evacuation. Your general purpose blade doesn't have that. It's just teeth all the way around. So it's going to be a lot rougher.
So if I'm the shop owner or shop manager and I want a blade that I can do just about anything with, these would be our 2 options.
Absolutely.
We talk about these 2 blades and tooth count comes into play. So tell us a little bit about tooth count. How does that affect saw blade cutting?
Definitely. So as everybody probably already knows, the higher your tooth count is, the cleaner of a cut you're gonna get. Our general purpose blade only has about 40 teeth on it, and our combination blade has 50. So with your combination blade, you are getting not only the gullets to keep it from getting loaded down, but you also have 10 more teeth. So that overall just proves that that is going to cut cleaner than this general purpose will.
And so you talked about the gullets, and so the main factor as far as these large gullets go is evacuation then.
Absolutely.
All right, to switch gears, you know, we're talking about miter blades as well. A lot of folks might not understand completely what the term miter means. So tell us a little bit about mitering.
Definitely. So the definition of that would be a finish cut at an angle. And how many woodworkers achieve this is they have what's called a miter box. And it has a preset degree of angles that it serves more as a template. Most of them that I see are at a 45-degree angle, so you have a leftward leaning 45-degree angle and a right leaning 45-degree angle. So all you have to do is guide the blade into the template and you're going to be able to get a really nice joint out of it. So millwork shops are really big for liking these blades, and like your picture frame industries as well.
And what's interesting as far as those angles are concerned is if you put two 45-degree angles together, well, what's 45 plus 45? 90. Put two 45s together, you have a 90. You do that 4 times, you have a picture frame.
That's exactly right.
And it works the same way with 22.5 degrees or 30 degrees. It takes a certain amount of them to make basically a complete circle or a complete square. So mitering has a lot to do with those angles, and you know, 45 degrees is by far the most popular. But when you get into putting up crown moldings or making you know, hexagon picture frames, so on and so forth, you get into different angles.
Absolutely.
We've thrown the term kerf around just a little bit, and a lot of people, even some experienced woodworkers I've talked to, don't understand what the term kerf means. I've been asked that question a lot, so tell us a little bit about it.
It's actually really funny that you said that, because I just got into an argument with my dad last week about what kerf is. But the best way to think of it is every time you make a cut, you are taking out a certain amount of material, like a certain amount is coming out of that cut. And what determines that is the thickness of the teeth.
Now we're getting into talking about thin kerf a little bit. So I imagine, based on what you just told me, that the less material you're taking out, the less resistance you're going to have in the cut. We're bringing in an entire line of thin kerf blades. Like I mentioned earlier, the thin kerf blades have gotten real popular in recent years, and a lot of people are looking for them. So tell us a little bit about the difference between a thin kerf and a standard kerf blade.
Definitely. They have become a lot more popular, but they each have their own set of advantages. So it really comes down to the customer's personal preference of them. Your standard kerf or full kerf is going to be more stable. It is also going to have straighter cuts. It's going to last longer simply because it's thicker teeth. You have more of the tungsten carbide to wear down with the thicker kerf, and it's going to be more durable in that realm as well. So it's also, to give you a number to put on it, it's about 1/8 of an inch thick. So thin kerf is a little over 1/16 thick. So thin kerf is about half the thickness of your standard or full kerf. And what the thinness allows for these blades is it's going to cut a lot faster. And like you said, it's going to have a lot less feed resistance. You're going to save about half the material over time. You might not see it at first, but over time you're going to save about double. And it's going to require less horsepower to operate. Your standard kerf is going to be a lot heavier than these thin kerfs are, so your saw is not having to work as hard to push it through.
And I was thinking about this a little bit too. You know, you might think that because the blades are only half as thick, the carbide is only half as thick, that it's not going to have a decent lifetime to it. But when you stop and think about the fact that the feed resistance is a whole lot less, well then all of a sudden you're extending the life of that carbide on that thinner kerf blade. So you might be surprised at what a thinner kerf blade will do as far as the life of the blade goes.
Definitely comes down to quality.
So which types of blades are we bringing in for the thin kerf?
So we're bringing in some thin kerf that'll go on a table saw and some that'll go on a miter saw. We are bringing in a thin kerf ripping like we spoke to earlier. We are also bringing in a thin kerf combination for those customers who still won't want to have to change out blades all the time. And then we are bringing in 3 different kinds of miter blades, which is huge.
So the combination, thin kerf combination blade, how is that a benefit to those listening?
So the biggest asset to bringing in that combination is that it still has the same design as the full kerf. So you're going to still get that great evacuation of material, but it's going to run faster. So where it's not having to fight to get through that material, you're getting really the best of both worlds. You're getting a faster cut and you are also getting a clean cut still.
And another interesting point about all this too is if you decrease that feed resistance, you're increasing the life of your saw. Your saw is not having to work so hard.
Exactly.
So that's another good benefit. We're bringing in 3 different kinds of thin kerf miter blades. Why 3?
The easiest way to explain it is for the machinery. We have a 10-inch with about 60 teeth that is for a standard miter. So you're not going to want to put that on radial arm saws or compound miters. For those machinery, we are bringing also in a 10-inch sliding or compound miter thin kerf blade, and that's going to have 80 teeth on it. And then last but not least, we're bringing in a 12-inch with 72 teeth miter, but it's going to be also allowed to go on to your sliding and compound miter saws.
So we could sit up here and talk about thin kerf miter blades for a long time, but I want to see them in operation. So let's head on down to the shop and take a look and see what these things can do. Well, you've had a look at our thin kerf miter blade, our thin kerf combination blades, seen what these things can do. They're beasts as far as I'm concerned.
Absolutely.
You know, you might think a thinner kerf is going to be a weaker blade, but you've just seen they are not. They do a really nice job. But that's about all we have for you today. Thanks for joining us for KLINGSPOR's Tech Talk. I want to mention too, if you have any questions, comments, you know, things you want to talk about maybe in a future episode, go ahead and email us at techtalk@klingspor.com and we'll be glad to get to your questions. Thanks for joining us. I'm Nick DeMars.
And I'm Nina Grum.